At this very moment, in the icy immensity that surrounds our small blue dot, something is watching us. The question is not whether life exists beyond Earth, but why we haven't found it yet. This is the greatest and most terrifying paradox in science, a cosmic abyss of silence that, for many experts, is proof that the end of humanity is already written. For centuries, we have looked to the sky with a mix of hope and fear. We have cataloged billions of galaxies, each one housing billions of stars, and orbiting those stars, trillions of planets. Statistically, the probability that life emerged in only one place is so close to zero that it defies all logic. The numbers scream that the universe should be overflowing, vibrating with civilizations so advanced that ours would seem like simple anthills. And yet, we find only emptiness. This is the great mystery, the great silence. But don't be mistaken. This silence is not necessarily an absence. It is an enigma. Are we being intentionally ignored? Or does advanced life destroy itself before reaching a cosmic level? The truth, though uncomfortable, might be hidden not on some distant planet, but right here, inside government files sealed for decades, in unexplained sightings documented by the Navy, and in signals NASA itself classifies as non-terrestrial. Today, M31 Andromeda will take you on a journey that will confront your perception of reality. We're going to expose the 6 most disturbing signs suggesting we are not alone, and unravel the darkest explanation of all, the Fermi Paradox. If before 5 minutes pass, you will understand why the answer to extraterrestrial life may be the omen of our own extinction. If you dare to face this truth, if you want to know what the heavens are truly hiding, if you're ready to see the 6 signs humanity is ignoring about extraterrestrial life, write, "Yes, I'm ready" in the comments right now, and let's begin this journey that will keep you awake. To understand the magnitude of the enigma, we must first accept the scale of the universe. Think of our galaxy, the Milky Way, a spiral disk of matter containing between 100 and 400 billion stars. Now expand your mind. The observable universe conservatively holds around 2 trillion galaxies. Multiply those trillions by the billions of stars each one contains. The number is so astronomical that any human mind finds it impossible to grasp. It is a magnitude that transforms Earth not into a home, but into a cosmic speck of dust. Now let's introduce the mathematics of life, formalized by the famous Drake equation in 1961. Although criticized for its numerous speculative variables, this equation gives us a logical roadmap. Consider the fraction of stars that have planets, which we now know is nearly 100%. The fraction of those planets that lie in the habitable zone where liquid water can exist, the probability that such life arises there, and then the probability that such life evolves into intelligence capable of communication. Even if we assign extremely low values to each of these variables, the final result always gives us one inevitable conclusion. There should be millions, perhaps hundreds of millions, of advanced civilizations in our Milky Way alone. If life is a natural chemical process, as demonstrated by the amino acids and organic molecules we find in meteorites and nebulas, then the conditions necessary for a primitive cell to come into existence are not a miracle, but a cosmic inevitability, given the right ingredients and enough time. The Milky Way is more than 13 billion years old. Our own star, the Sun, is relatively young.
This means billions of stars have had billions of years more than ours to generate life, for that life to evolve, to build telescopes, spacecraft, or even interstellar communication networks. The problem, the desert within this oasis of probabilities, lies here. With trillions of opportunities, where are all those civilizations? Why do our radio telescopes, like the SETI project, capture only the cold whisper of background noise? It's as if we've entered a massive global city with millions of inhabitants, only to find the streets empty and the lights turned off. This silence is so loud to astronomers that it has become an obsession. It is evidence that our understanding of life, the universe, or worse, technology, is fundamentally flawed. The possibility that we are the only flame burning in this darkness is statistically the most absurd of all hypotheses, yet it is the only one we can confirm. It forces us to ask, if the mathematics are on our side, what unknown force is working against us? This question is the engine of the second great topic, the Fermi Paradox, which reveals why this silence is not a blessing, but a warning.
If the probabilities, as we have just seen, point to a universe overflowing with life, then we face the greatest cosmic contradiction, the Fermi Paradox. Named after physicist Enrico Fermi, who in 1950, during an informal conversation about UFOs, asked the now iconic question, if the universe is so big, where is everybody? This simple question encapsulates existential terror. If civilizations far older and more advanced than ours exist, why haven't we seen their megastructures, their exploratory ships, or at the very least, their radio transmissions? A civilization ahead of us by only a few thousand years, a speck of time on the cosmic scale, should already have mastered interstellar travel. Using the concept of Dyson spheres, they could have encapsulated their stars to harness their full energy output, leaving a detectable technological footprint across light years. If an advanced civilization had begun colonizing the Milky Way at an astonishingly slow speed, just 1% of the speed of light, our galaxy, from end to end, could be colonized in only a few million years. And given that the universe has had billions of years to accomplish this, they should have arrived here by now, or at least their automated probes. But again, the silence is absolute. This great silence forces us to consider the darker implications of the Fermi Paradox. The most famous of them is the Great Filter hypothesis. This theory proposes that there exists an evolutionary barrier so devastating and so common that it prevents almost all life in the universe from reaching the stage of an advanced civilization, and more importantly, from escaping their home planet. The Great Filter could be behind us, a unique miracle we've already surpassed. Perhaps it was the emergence of multi-cellular life, or the leap from prokaryotic to eukaryotic cells. If this is the case, then we are the exception, the lone survivors on the verge of spreading across the galaxy, and we have nothing to fear. This is the optimistic view, but the evidence, or rather the lack of it, suggests something far worse. The most terrifying possibility is that the Great Filter lies ahead of us. It means that most civilizations reach a certain point of development, the very point at which we stand right now, only to encounter an extinction wall that is nearly impossible to overcome. This wall could be a self-inflicted nuclear war, a global climate catastrophe that wipes out the biosphere, or an uncontrollable artificial intelligence. It is the grim conclusion that every civilization, upon reaching a certain level of technological power, carries within itself the seed of its own annihilation. If we don't see anyone else, it's because all of them failed at this critical point.
The Great Silence, then, is not a mystery. It is a cosmic warning. It's not that the universe is empty. It's that our neighbors, before we could ever greet them, blew themselves up. And we now stand at the threshold of that very same doorway.
After diving into the cold logic of extinction, it's only fair to turn toward where science places its most tangible hope: exoplanets. Thanks to missions like the Kepler Space Telescope and more recently the James Webb Space Telescope, the hunt for worlds has shifted from speculation to certainty. We now know that every star in the sky has, on average, at least one planet orbiting it. That's trillions of worlds. But what obsesses us is not just the quantity, it's the quality. Finding a planet in the habitable zone of its star, at just the right distance for liquid water to exist on its surface. But the mere presence of liquid water is not a definitive biosignature. The real game of detecting life begins with atmospheric spectroscopy. When starlight passes through the atmosphere of an exoplanet, we can analyze the chemical signatures, searching for gases that shouldn't naturally be there. We're looking for the fingerprint of life. Two gases in particular are biology's screams: oxygen and methane coexisting in large quantities. These two gases react with each other and neutralize quickly. Therefore, the only way they can coexist in significant amounts is if something biological, something alive, is constantly producing them. And this is where the intrigue intensifies. There is a system that has captured the attention of the scientific community in an almost obsessive way, though it is handled with extreme caution. TRAPIST-1. This system contains 7 Earth-sized planets, all orbiting a relatively cool red dwarf. 3 of these planets are directly in the habitable zone. While tidal locking is a possibility, leaving one side frozen and the other scorching, their atmospheres are being analyzed with unprecedented precision. And it's not the only candidate. The planet NASA has secretly classified as Candidate A is in fact an exoplanet about 40 light-years away called LHS 1140b. It is a super-Earth orbiting a red dwarf star. What makes this world fascinating is not only that it lies in the habitable zone, but that preliminary Webb data has suggested a possible haze in its atmosphere, one that some theorists propose could be caused by biological processes or, more controversially, by byproducts of advanced technology. Although science insists on caution, there are always geological explanations. The intensity of the research devoted to LHS 1140b and similar worlds shows that scientists don't just believe life exists, they know where to look for it. They are a single spectrum away from making the biggest announcement in human history. For now, the only secret is the inability to confirm beyond any doubt whether that haze is breath or steaming rock. But the intensity of the search suggests that the answer could arrive tomorrow.